And good morning, fourth grade students of Mr. Leggett's class. Welcome to Eureka Math. Now, I hope you do remember what Eureka means in the language called Latin. It means, I have found it. And what have we found? We have found the best way to learn math. And as you know, the 49ers would shout Eureka when they discovered gold or found some gold. And I think learning math this way is more valuable than gold. I've told you that many times, and I believe it. So we have our piece of paper here. We have the application problem on the back. Here's our front and back. And our fluency practice right up here. So the first thing we're going to do is add and subtract fractions. And we'll get rolling on this in a second. You don't need your whiteboard yet, or scratch paper yet, because you have this piece of paper to work with. So let's start off with some number bonds. Going to start off with 3, and we'll break that down to 2. And what would we put on the other side? We could put a couple of things. So let's talk about it as fourths. How many fourths should we put here to equal 3? Well, of course, it would be 4 fourths, and go ahead and write along with me. So there we have that. Now what we're going to do is we are going to write out 3 minus 1/4. It's a whole new problem here. Equals what? Equals 2 plus what? What? Addition? Yeah. 3 minus 1/4 would equal, there's the 2. So we know that 4 quarters minus 1/4 would be, you got it, 3 quarters. And so our answer would be 2 3/4. Okay? Let's take a look at another one. And this problem is, let's do 5 minus 5/6. Okay? So what we're going to shoot for now is breaking this down, the 5, and it will be 4 and 6, 6, right? That equals 5. 4 plus 1 whole is 5. So we could take this now and figure this out, that this would equal 4 plus what? Well, we take our 6/6, it's part of that 5, and subtract 5/6. What would we get? Well, 6 minus 5 is 1, so we would get 1/6, and that would equal 4 1/6. Try another one. We'll do something a little different here. We're going to go 6 plus, because it does say add and subtract fractions up top. Oops, I'm so sorry. 6 3/5 plus a number equals 7. Well, you could probably already figure that out, but let's just kind of break this down a little bit, okay? Let's say we have, break down our 6 here to, well, what we could do is see what we could add to 3/5 to get 7. 3/5 to get 7. Well, I would know that 3, we would need to get, how many more fifths to get to 7? We would just need 2/5. Because 3 plus 2 is 5, and then we have the 5/5. Not a very good looking 5, Mr. Leggett. Let's continue on, and let's go back to subtraction. And we'll do 7 minus 2/5. And we could break this 7 into a 6. And what would go over here? If you said 5/5, you're absolutely correct, because now we have 7. And this will equal what? Think about this for a while. What's this going to equal? It's going to equal a number plus a fraction will equal something, okay? So we have our 5/5, and we take our 5/5 and minus 2/5, so we get 6. 5 minus 2 is 3, plus 3/5 would give us 6 and 3/5. We could reverse this process too and just do 6 and 3/5 to check, plus the 2/5 equals what? 6 plus 1 whole would be 7. All right. Let's move on to our application problem, and that's on the other side of your paper. And we'll get going on this in just a second. So let's start on this, and let's underline what we know. Well, we know that Mrs. Fowler knew that the perimeter of the soccer field was 1/6 of a mile. So that's what we know. I bet that 1/6 will be in the problem when we do the math. Her goal was to walk 2 miles while watching her daughter's game. So we'll circle 2 miles because I have a feeling that will be there. If she walked around the field 13 times, did she meet her goal? Explain your thinking. A lot going on in this problem. Well, let's start off with 13 times. So she walked 13/6, right? Because she walked around 13 times, and each time was a 6. So we'll do 13/6. She walked 13/1/6 of a mile. Tighten up a little bit. There we go. So she walked 13/6 of a mile. Well, that would equal 12/6 plus 1/6. And we did 12 because 6 times 2 is 12. Figure out how many 6s fit in there. So we had 2, so 12/6. And then to get to the 13, we added another 6. So what does 12/6 equal? Well, think about it. 12 can be divided by 6 2 times, so we would know it would equal 2, and we're left with 1/6. The way we got over here, think about it this way, we just want 12/6 and 1/6 to get 13/6. There's another way we could approach this problem. Let's do that this other way, an alternative route. We could have gone 13/6 equals 2 times 6/6 plus 1/6 equals what? Well, let's look at this problem. 2 times 6/6. Well, that's 2 times 1, isn't it? The 6/6, the 2/6/6 up there. So that would just give us 2 and 1/6. Then we could do a number line as well. So let's do our number line. And we should start at 0. And we'll probably have to go all the way to 3, wouldn't you think so? Because we have 2 and 1/6. So we'll go 1, 2, and we have 3. What should we break these into? We should break them into 1/6, right? 1, 2, 3, 4, 5, and that's 6. 1, 2, 3, 4, 5, and that's 6. 1, 2, 3, 4, 5, and that's 6. So she walked a total of 13/6, right? And look, we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and know it's 2 and 1/6. But let's kind of break it down how we did it up top with the 12/6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we add on, boo, 1 more 6th. So now they've asked us to explain it, okay? Explain your thinking. We've read, we've drawn, now we write. Mrs. Fowler met her goal. Remember her goal was to walk 2 miles? Whoops. 2 miles would be 12 laps. And she walked 13. 2 and 1/6 is greater than 2. And that's miles and miles. So write that down. We're going to be turning this in later on. Some of your math notes grade. If you have to freeze the video, feel free to do that. We're going to move on to our concept development. The concept development. I'm going to grab some scratch paper so we can do this upright. You can get out your whiteboard and your or some scratch paper. Pause the video if you need to. Set my timer again. And let's get busy with the concept development. Okay. First thing we're going to be doing, our goal today is, let's take a look at it, is to decompose and compose fractions greater than 1 to express them in various forms. All right, let's dig into that. So our first thing we're going to do is model with a number line to convert a mixed number into a fraction greater than 1. All right? So we're going to take a mixed number and convert it into a fraction greater than 1. And so we're going to wind up with an improper fraction. We're going to start off with 2 and 1/6. We just dealt with that number, didn't we, with Mrs. Fowler? So what are we going to, how many 6 are there in 2 1s? Well, we can go like this to show 2 and 1/6. And then we could cross out that 2 and make it 12/6, because that's 2. 12 divided by 6 is 2. 12/6 equals 2. So 12/6 plus the 1/6, what does that equal? Well, thinking back to Mrs. Fowler, it equals 13/6, right? So we're going to write this out again. We're going to say, let's write it down just a little bit below. We'll say 2 and 1/6 equals 12/6 plus 1/6 equals 13/6. And let's show this on the number line one more time. Even though we did that with Mrs. Fowler, it's really a great way to do it. And we'll just go, start with 0, end at 3. We have a 1 and a 2 in there, 1 and 2. We're going to make these 6, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So 13/6, 6, 12, 13. This is where we're going to wind up. I'm going to start my arrow there, but we're going to do the 12/6 first. Boink, right at 2. 12/6, and then dink, another 1/6 to get that 13/6. So we can see that 2 and 1/6 is equal to 13/6. That's the mixed number, and that is the improper fraction. So go ahead and erase your whiteboard, or get another piece of scratch paper. If you can still work on that scratch paper, that's fine. We're going to do another one here. It's going to be 3 and 1/3. And we're going to convert this into an improper fraction, our fraction greater than 1. Remember, if the numerator is larger than the denominator, it is indeed greater than 1. So what number could we do over here? Well, we have our 1/3. And I know 3 can be, if it's a third, right? We're dealing with thirds, so 3 times 3 is 9. So 3 and 9/3 are equivalent. So we could come up down here and we could say 3 and 1/3 equals 9/3 plus 1/3 equals 10/3. And we're going to prove this on a number line, because we're at 3 and 1/3. I'll have our number line go all the way up to 4. and 0 and 4. And then we'll go 1, 2, 3. There's my 1, there's my 2, there's my 3. And now let's break this into what? Into thirds. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So how many thirds do we have? We have a total of 10 thirds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 and 1/3. So our first one was 9 thirds, and that's going to land us right at number 3. There's 9 thirds, and then we had one more third. And that gave us 3 and 1/3. So 3 and 1/3 is equivalent to 10 thirds. If you don't believe me, let's just take a real quick look at a tape diagram, and we'll do 1. These are all equal to 1, 2, 3, and I'm going all the way to 4, and we'll break these into thirds. Remember, all of these are equivalent to 1. All right, I'm going to put a bracket that will show that they're all equivalent to the number 1. All right, so let's break them down into thirds. 1, 2, and 3, 1, 2, and 3, 1, 2, and 3, 1, 2, and 3. Well, 3 and 1/3. Let's go ahead and shade these in. Here's 1. Here's 2. Here's 3. And there's a third. How many thirds is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 thirds equals 3 and 1/3. All right, let's continue on to our next one. We're going to use multiplication to convert a mixed number, a number with a whole number and a fraction, into a fraction, an improper fraction. Well, or never. I like saying that one. All right, so here we go. We'll start off with 4 and 1/4. And we're going to use multiplication to turn this into an improper fraction, or a fraction greater than 1. And we'll start off with breaking this down to 4 and 1/4. So what we're going to do is we're going to go 4 times 4/4. You see, it's just 4 times 1 plus 1/4. That's how we're going to set this problem up. So we have 4 plus 1/4, right? Dig me? Got it? What is this going to equal? Well, it's going to equal 16/4, right? 4 times 4 is 16, before the denominator's on the bottom, plus 1/4. Always do those parentheses first. What do we get? We get 17/4. So 17/4 would be equivalent to 4, and 1/4 would equal 17/4. And we can make those tape diagrams and all that to show it, but I think hopefully we're getting the hang of it. When you think about there's 4/4 in 1, we got 4 of them, to be 16/4 plus the 1/4 would be 17/4. Okay, we're going to take a look at 2 and 2/3, and I'm not going to do this problem in its whole for you. You're going to have to do some of it on your own. So we're going to do 2 and 2/3 equals blank times a fraction plus a fraction, all right, equals a fraction plus a fraction equals a fraction. All right, so that's how we're setting the problem. Go ahead and hit pause and try this on your own. And if you get it, fantastic. If not, we're going to share a little bit. I'll give you a little bit of a hint, and I will put a 3 right here. All right, go for it. Welcome back. Here we go. Hopefully you got this one right. We're going to go 2, right, times 1 times 3/3, right? So we have that right there, and then that's going to be plus what? Well, we got to plus that 2/3 over here. So we're going to wind up with 2, right? 2 times 1 is 2, plus the 2/3. But now we bring it down here to fraction time. We get 2 times 3 is 6, so we have 6/3 plus 2/3 equals 8/3. thirds. So 8 thirds is equivalent to 2 and 2 thirds. Now, we could do it a simpler way, kind of, and I'm going to show you a little trick that we do in 5th grade. We could go 2 and 2 thirds, and you could write this along with me. Scribble that out. We'll say 2 and 2 thirds equals, and think this is another way of looking at this, okay? It equals 2 times 3 over 3 plus 2 thirds. Now, what is this going to equal? Well, it will equal 2 times 3 is 6, right? So we have 6 over 3, and we still have to add on the 2 thirds. Remember, we do the parentheses first, and that will another way to equal 8 thirds. Okay, now we're going to be using a little mental math to convert a mixed number into a fraction greater than 1. So look at 3 and 4/5. Create a picture in your head. How many ones and how many fifths? Well, we have 3 ones, right? And 4 fifths. You all agreeing with me? Yeah, I do. So think about it like this. 1 would equal 5 fifths. 2 would equal 10 fifths. And 3 would equal 15 fifths, right? So think about, now that we've got this all down, we have 5 fifths, 10 fifths, 15 fifths, right? So we could just go, the 15 fifths is 3, right? There's our 3, there's our 3. So all we need to do is go 15 fifths plus 4 fifths equals what? 19 fifths. And there you have it. Really cool way to do it, I think. The object here is try to get you to do this in your head. Let's do another one with 4 and 2 thirds. So you have 4 and 2 thirds. What mixed fraction, what improper fraction will this mixed number be? Think about it. 1 equals 3 thirds, right? What would 2 equal? 2 would equal, 6 thirds. What would 3 equal? 9 thirds. And what would 4 equal? 12 thirds. So think about it now. Pause the video and think about what your final answer is going to be. Okay, if you took your 12 thirds, welcome back, and you did 12 thirds plus 2 thirds, it would equal 14 thirds. Okay, and we're going to prove that just with tape diagrams because I really want you to understand this, okay? So let's come on over here and we'll do one number. Remember, these are all number 1. 1, 2, 3, and our number was 4 and 2 thirds. So there's our 4. All of these represent the number 1. Let's go 1 third, 2 thirds, 3 thirds, doink, 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 doink. And so we're going to color in, this would be 1 whole, 2 whole, 3 whole, 4 wholes. But remember, our number is 4 and 2 thirds. So Mr. Leg is going to draw another tape diagram to show the 2 thirds. Right? Here we go. 1 third and 2 thirds. There it is. 4, 1, 2, 3, 4, and 2 thirds. And let's count and see how many there are. We said 14, 3, 6, 9, 12, 13, 14. So 14 and 2 thirds does indeed. We've proven it over and over again, or at least 2 times, that it equals 14 thirds. We're going to get out our problem set. So go ahead and get out your problem set booklet while Mr. Leggett goes and grabs his problem set. And it's problem set 25. We got page 189 and 190 to Today's date is 04/11/19. Well, it's 11 for me because I'm doing this last night. And we're going to have to zoom in a little bit so we can get a better look at our math here. Excuse me while I zoom in. Whoops. Better look at our problem set. Okay, that's looking pretty good, I think. Alrighty, so our instructions are to convert each mixed number to a fraction greater than 1. We need to draw a number line to model your work. If you think you can handle this and go and do it on your own, go for it. So here's our number line, 3 1/4. We had to go to 0 and 4. We came down here and did 3 1/4 equals 3 plus 1/4, which would be 12/4 plus 1/4 equals 13/4. There's our 12/4 plus our 1/4, okay? Let's give it a shot with this 2 4/5. We do the number line first. And because it's 2 4/5, I'm going to go from 0 to what? 0 to what number? Uh-oh. Here comes the problem set night. What am I going to go to? That's too many. Well, he's not much of a help. So, we're going to go to 3. And we'll have 1 and 2 here. 1 and 2. And we should break them down into fifths, right? Because we have 2 4/5. So we'll go 1, 2, 3, 4, and 5. And 1, 2, 3, 4, and 5. And 1, 2, 3, 4, and 5. Okay? So with this in mind, on our 2 4/5, let's break it down now that we've got this all lined up. Let's do a math sentence here. And we'll go 2 4/5 equals, in fifth land, what would this be? What could we do? I know it's going to be 2, right? Plus 4/5. So in the 2 plus the 4/5 would be 2 4/5. We're going to break down our 2 into 10/5, right? To show 2. And then we're going to add 4/5. So we would wind up with what? 14/5. And that should equal 2 4/5. Let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Looks like 2 4/5 to me. So the first thing we did was 10/5. That gives us right to 2. And then we added the 4/5. Boo! So we got 14/5. So 2 4/5 is equivalent to 14/5. Let's look at 3 5/8. We're going to do our number line first. Give us a little more room. And what should this number line go to? Well, it's 3 5/8, so it should probably go all the way to 4, right? So we go 1, 2, 3, and 4. There's our 1, there's our 2, and there's our 3. We got to break them down into 8s. Boy, there's some mean folks over at Eureka Math doing that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You can hardly see my 8s. So, first thing we're going to do, make our the next thing we're going to do. We're going to go 3 5/8 equals 3 plus 5/8, which would equal what? Well, I have to deal in 8s, right? So 8 times 3 is 24. That'd be 24/8 plus 5/8. What will that equal? Remember, the denominator doesn't change. 24 plus 5 is 29. So you have 29/8. Does that equal 3/5? 3 5/8? Let's take a look. 8, 16, 24. So there's my 24/8, and we add on 5/8. 1, 2, 3, 4, 5. I can hardly see those 8s, they're so tiny. And it looks like we get 3 5/8. Let's do our next one as tenths, okay? I'm going to make this number line a little bit longer. And what should the number line go to? I'm not going to ask the problem set night because he just keeps on clicking and clicking and giving me all sorts of numbers. It should go to 5 because 4 and 4/10, the next number would be 5. So we'll go make a 5 over here. And we'll go 1, 2, 3, 4. I don't think I'm going to have enough room. 1, 2, 3, 4, and 5. And they want us to do tenths. Oh my goodness. Let's make it happen, kids. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so there we have that. Let's break it down and see what we wind up with. Okay, we're going to go 4 and 4/10 equals 4 plus 4/10, right? Equals, we got to keep it at a tenth, all right? And we got to do the 4 first, so 10 times 4 is 40. 40 plus what? Plus 4/10. So 40 plus 4 is 44, and we wind up with 44/10, okay? So let's see what this would look like. 10, 20, 30, 40. There's my 4. Or 40/10. But I have 4 more to go. 1, 2, 3, 4. Ding. Plus my 4/10. I'm going to equal 44/10. So 44/10 is the same as 4 and 4/5. Let's go in here to 4 and 7/9. I'm making this one even a little longer. So 4 and 7/9, what should we go up to? Here's my 0. What's going to be over here? If you said 5 and wrote down 5, you're absolutely correct. And we'll go 1, 2, 3, 4. 1, 2, 3, 4. What are we breaking these down into? We're breaking them down into ninths. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So all of these, this one is a 9/9, 9/9, 9/9, 9/9, 9/9. How about that? So let's go ahead and do the math, and I've run out of room, so I'm going to put it down here. And we'll do 4 and 7/9 equals 4 plus 7/9 equals, we got to keep it at ninths, right? I already have the 7/9. Now I do 9 times 4 to get 36. So 36 plus 7 is what? 43/9. Let's see if 43/9 equals 4 and 7/9. Let's see. 9, 18, 27, 36 is my 4. That's 36/9, right? 9, 18, 27, 36. But we still have to have the 7/9. 1, 2, 3, 4, 5, 6, 7. I'm going to put my arrow there so I don't lose place. Plus 7/9. So 43/9 does indeed equal 4 and 7/9. Let's look at the back side of our problem set. See what it says. It says convert each, no, that's what we got to do, each mixed number to a fraction greater than 1. Show your work as in the example. And we're using multiplication. Note that 3 times 4/4 equals 3 times 4 over 4. So 3 and 3/4. 3 and 3/4 equals 3 plus 3/4 equals 3 times 4/4 plus 3/4 equals 12/4 plus 3/4 equals 15/4. Wow! Let's look at it a little slower. 4 and 1/3. It equals 4 plus 1/3. That equals 4 times 3/3. Which equals 4 times 3 is 12. And the 4 of the 3 will remain the same. Plus 1/3 equals 13/3. Whew. No, that's kind of confusing, but we're going to get this. We could say 4 3/5 equals 4 plus 3/5. Whoops. Equals 4 times what? Think about it. We're dealing with fifths, so it'd be 4 times 5/5. Okay, now that's going to equal what? Oh yeah, we're fine. No, I forgot something. I forgot the plus, I'm sorry, the 3/5 over there. And I forgot the plus 1/3 over there. Forgive me. So we have 4 times 5 plus 3/5. Well, what will that equal? 4 times 5 is 20, right? So it's 20/5 plus 3/5 equals 23/5. Let's start on this one, and you're going to kind of handle this one on your own. 4 6/8 equals 4 plus a fraction equals 4 times a fraction plus a fraction equals a fraction plus a fraction equals a fraction. Fraction, fraction, fraction. No more, Mr. Leggett. Okay, it's up to you to fill those blanks in. Go ahead and pause the video. And let's take a look. If you're ready to go, you've paused the video, you want to check your work now. So we'll do this. 4 plus what? It's 4 plus 6/8, right? It's 4 times what? We're dealing in eighths. So 8/8. 4 times 1, basically. We're adding 6/8. So what we get, this is equivalent to what? 4 times 8 is 32/8, which equals 4. 32 divided by 8 is 4. See how it all works there? Now we're going to add on that last 6/8, and it's simple math from here. The denominator does not change. Ooh, look. And 32 plus 6 is 38. So 38/8 equals 4 6/8. Okay, our next segment is convert each mixed number to a fraction greater than 1. And these are the ones you're doing in your head. Think about it. Let's just try to think about this as in our heads. Okay, we're dealing with fourths. So we're doing a fourth plus 3/4. How many fourths are in 2? There's 4/4 in 1, so there's got to be 8/4 in 2, and that would equal 11/4. Go ahead and continue on if you're comfortable. If not, you could follow along with me. We're going to do a fifth plus a fifth will equal a fifth of some sort, right? So I know that's 2/5, but how many fifths are in 2? Well, there's 5/5 in 1, so 5 times 2 is 10. And there's our answer, 12/5. Let's look at this one. It's going to be a sixth plus a sixth, 3/6, and it will equal a sixth. Well, look at this. There's 6, 6, and 3. What's 6 times 3? 18. So it's 18 plus 3 is 21/6. 3 3/8. We look at this, it's going to be an eighth plus an eighth, and it'll equal an eighth, right? So I know one of those eighths is 3/8. 8 times 3 is 24, right? Because there's 24 eighths and 3. We'll be chopping up each number into a section of eighths, and we're going to get 27/8. We'll head on over to